Hello everyone, welcome to lesson 4 of our GoLang course. In this lesson we are going to look at floats and complex numbers together, as complex numbers are formed using floating numbers. In this lesson, first we will cover the float data type, then the complex data type, and finally we will look at some code. Floating point number, or just floats, have an integer value, a decimal point, and a fraction value. If you remember from our integer data type lesson, the integer data type doesn't support the saving of fractions. To fill that need, we have floats. Go, like many modern languages, implements floats in accordance with the IEEE 754 standard. This broadly means that the storage of floats in memory is divided into 3 parts. A single bit is used to store the sign of the value, a few bits are used to store the integer value, and the rest are used to store the fraction. This also means that the precision of floats in Go is limited. They should be used very carefully. It is not advisable to use floats for monetary values due to lack of precision. I will link some articles related to the standard that you can read to understand the inner working of the IEEE 754 standard and the inherent lack of precision. The lack of precision also means you should be careful when comparing floats for equality. Instead of directly comparing the floats, the delta of two floats should be compared to see if they are equal or not to a pre-decided value. If the delta between the two floats is greater than the pre-decided value, they should be deemed unequal or equal otherwise. Just like our integer data types, there are two float data types. The difference between them is the memory they use to store the values. Float 32 data type uses 32 bits of memory to store the value, while float 64 uses 64 bits of memory to store the value. The default data type for float is float 64. I have added the range of floats here, but to understand it more, please refer to the IEEE 754 standard. Complex numbers are a data type in Go, but they are not widely used. It is rare that you will come across Go code that uses complex numbers, but for brevity, we'll cover them in this lesson. A complex number in Go has its real and imaginary parts represented by floats. There are two complex data types, and they are complex 64 and complex 128. Complex 64 uses float 32 to represent both the real and imaginary parts. Similarly, complex 128 uses float 64 to represent the real and the imaginary parts. The built-in function complex can be used to create a complex number, while the built-in functions real and imag can be used to extract the real and imaginary parts. As mentioned before, complex 64 uses float 32 to represent the real and imaginary part, and complex 128 uses float 64 to represent the real and imaginary part. Let's look at some code now to get a hang of it. As we have done in previous coding sessions, first we will create a main.go file. Inside it, we will have package main and then func main. So to start off, we will create a float 32 variable. Small float 32. The 0 value for floats, as with other number values, is 0. So if I do fmt.println small float and then run a program, go run main.go, you will see 0 printed. Now let's assign a value to our small float. So I can assign a fraction value. Let's now try to print it. fmt.println small float. Running the program again, go run main.go. You will see the fraction part is printed, but it has been limited and some of it is truncated. That's because, as mentioned in the lecture, the precision is limited, so it only saves a bit of the fraction part. Now let's create another float variable, big float of float 64. Again, if I do fmt.println big float and run the program, you will see 0 is printed as the default value, or the 0 value. Now if I assign big float a value and then do fmt.println big float, running our program, you will see the precision is greater. That's because it's using more bits in memory to store the value. But if I exceed by a limit and then print the value again, we will again see that it will be truncated. So it printed till here and then rounded it. So as described in the lecture, you should be careful while using floats, especially for monetary values, and also when comparing floats. Instead of comparing floats directly, you should use a delta and see if the difference between the two floats is greater than or within the range. If it's within the range, you should consider the two floats equal, but if it's outside the range, they should be treated as not equal. So now let's look at the complex data type. var myComplex is of type complex 128. Now to assign a value, I will use the inbuilt function complex. So I'm going to use our previously created big floats to fill in the real and imaginary parts. Now if I do fmt println myComplex and run the program, you will see it prints an imaginary part and the real part, and again the precision is limited. The default type is complex 128. My complex variable is of type complex 128. I'm not going deep into complex numbers because you rarely see the complex number being used in a Go code. Go is not really meant for mathematical programming, but if you want to use it, you can leverage complex numbers. Now you can extract the imaginary and the real part. So to extract it, we can do var my real part and my imaginary part. Again, since we use complex 128, these both will be of type float 64. If you see here, you can declare two variables on one line like this if they are of the same type. So now I can do my real part is equal to real my complex and my imaginary part emag my complex, and then I can print both of them, my real part Now if we run the program, you will see it has extracted both the real and imaginary part. We use the same floats, so that's why the value is same, but if you use different, it will be different. That's it for our coding lesson. Floats can be used for regular use, but again, I will caution you against using them for where precision is required, especially for monetary values. Thanks for watching the lesson. If you have any questions, please leave a comment below the video, or you can use the Discord server to reach out. I will see you in the next lesson. Happy coding.